Assalamu alaikum. Good evening, everyone. Today, our topic is the quantum numbers, which is a very important topic, and most of the students I've seen that they're facing difficulty while explaining this concept. So, I'll try to make it simple, actually. And while working on this concept, we need to understand one thing that actually the quantum numbers are some of the properties of the orbitals that we are discussing actually. So when it comes towards the orbitals, you must understand that there are shells, okay, around the nucleus. Shells are having subshells. This is the simple language, and subshells are having orbitals. Keep in mind. Nowadays, the shells are called the energy levels, and the subshells are called the sub-energy levels. So, energy levels, okay, and subshells are sub-energy levels. Energy levels, okay. Nowadays, the name is given. So, what we see there in the orbitals, we find electrons in the orbitals, and the electrons are having then spin, okay. So, we are going to discuss these things, but in technical language. Right, so how many quantum numbers are there? Let us see. There are four quantum numbers basically. And the first one is the principal quantum number that is representing the shell. So it is represented by n actually, and it has values 1, 2, 3, 4, 5, 6, right? So when we talk about the principal quantum number, it is related to the size and energy of the orbital. As the number of n increases, the orbital becomes larger and the electrons spend more time further from the nucleus, and an increase in the number of n also means higher energy because the electrons are now tightly packed and they're bonded to the nucleus, and the energy is less negative at that time. So this is the principal quantum number. So if you can see how many shells are around the nucleus, there are 7 shells, so 7 principal numbers are there actually, right? Now let us move further more. What do we have after the principal quantum number? The second one is the angular quantum number. Angular quantum number is represented with the value of L, okay, and L is an integral value which is starting from 0 and n minus 1, right? So this quantum number is related to the shape of the atomic orbitals, and we'll talk about these shapes in another video properly. The value of L for a particular orbital is commonly assigned a letter. Like, for example, L is 0, right? Then it will be called S. When L is 1, it will be called P. When L is 2, it will be called D. And when L is 3, it will be called F, right? So there's a table given there, 7.1. After this slide, you will see these values are quite clearly mentioned there. So these are actually now the subshells. So the angular quantum number is representing the subshells now. You can see the value of L. If you have 0, you're talking about subshell S or orbital, or you can call it the sub-energy level now, not the orbital. And if it is 1, it is P, it is 2, it is D, it is 3, it is F, and 4 is G actually, which you cannot see that, but G is a little bit higher energy. So the angular momentum, quantum numbers, and corresponding letter used to designate atomic orbitals actually. So first of all, we talked about the principal quantum number, which is showing the shell or the energy level, and now we are talking about the atomic orbitals. And let us move towards magnetic quantum number. Magnetic quantum number is represented with ml. The magnetic quantum number has the integral values between L positive and L minus, including 0 also there. The value of ml is related to the orientation of the orbital in the space relative to other orbitals in the atom. So this is basically how three-dimensionally the orbitals are arranged in the space. So this is giving us a shape in the form of orientation. Orientation basically means how it is arranged in the space three-dimensionally. How does it look like, in fact? So this one is talking about the look or the shape of the orbital actually. Then moving on to the spin quantum number, when you enter into the orbitals, you find the electrons there. So two electrons are actually there. One electron will be spinning clockwise, and the other electron will be spinning anti-clockwise. So that's why when you put two negative charges close to each other, these two negative charges are going to be how they're going to be living together, because negative and negative is basically having a repulsion. So to overcome that repulsion, what the scientists have studied about it, that this repulsion is only and only possible to be overcome when one of the electron is spinning clockwise and the other electron is spinning anti-clockwise. So right, if you can see there, the spin quantum is mentioned there, right? So if one of the electron is generating, see the south and the north being generated there, external magnet and external magnet, the north and the south being generated there. So one is spinning clockwise, right? This is the clockwise movement, and the other is spinning anti-clockwise. So if this one is generating, for example, north, this will generate south, and then there will be attraction. So if I say in terms of charge, if this is generating negative charge by spinning clockwise, this will generate positive charge by spinning anti-clockwise. Anything which is spinning according to the right-hand rule of the physics, it has a magnetic field around it, right? So this magnetic field, if it is the movement of the charge is up, the magnetic field is like this, and vice versa. So this spin quantum number is telling us how to keep the two electrons together while you are working on the electrons and you're trying to bring them in one particular orbital. Here's the summary for you. So number of orbitals, we have S, which is one kind. You can see one is written there. P is of 3 kinds, D is of 5 kinds, F is of 7 kinds, and G is of 9 kinds. And every kind is can particularly accept 2 electrons there. So number of electrons will be 2 in it. So S will be accommodating 2, P 2 times 3, which will give you 6 electrons. Here 6 electrons. D will give you 5 times 2, 10 electrons. F will give you 7 times 2, 14 electrons. And G will give you 9 times 2 makes 18 electrons there. Okay, now if you look into this, the principal quantum, the magnetic quantum, you can see there the values there. For the first one, 1, L value is 0, and then it is the first shell S orbital there, and you can see 0 value is given there with the last quantum number. Number of orbitals, one type. P is of 3 types, you can see here. It is between L minus 1 and plus 1, so these are the 3 values given to it. So 1, 2, 3 give you 3. And if you move on to D, it's 0, 1, 2, 1, 2. The total number is 5 there. If you move on to F, you will find 0 to 1, 2, 3, and 1, 2, 3. So total 7 orbitals are there. So this is the overall summary of the orbital and the quantum number concept. Hope this will clear some of your doubts, and if still some of the questions are there, you can put these questions in the chat, and you can ask the questions there. Thank you very much. Have a blessed time and have a wonderful day. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.